Okay, in this next video we're going to do 9 through 14 and we're going to work with some fractional exponents and some radicals. And so in number 9 we're going to just show a radical conversion from exponent form to radical form. And the big thing to remember here is that the denominator is the index of the radical. So this would be the same as, there's a few different ways to look at this, but this would be the same as the cube root of 2 to the 4th power. Okay. And so what that means is if I cube, you could look at that a couple of different ways here. You could say, okay, well that's the same as the cube root of what's 2 to the 4th power is 16. And then we know there's a perfect cube 8 in there. Or you can say, well, this is a product of the cube root of 2 cubed times the cube root of 2. And so in simplest radical form, this would end up being 2 cube root 2. Number 10, we have a power to a power property, but we have a fraction. And so remember, if you have a power to another power like this, you multiply their exponents. So this is x to the 6 times 1/2 or x to the 3rd. Same thing with number 11. We have a power times a power, so this is a product of powers. And in this case, we would add these two exponents. So 5/4 plus -1/4 would give you a total of z to the 4/4, which we all know as z to the 1. And nobody ever writes the exponent to the 1. So that would be the same as z. Number 12, we have a 4th root of 256. And I'm not super great with all my perfect 4th roots, but I have my little table of powers with me here. And it is in fact a perfect 4th root. It is 4 to the 4th. So 4 to the 4th power is 256. So I'm going to break this up into perfect 4th root factors. If I look at the variable part, 9 is not a factor of 4. So I'm going to break this up into factors of x that would be a multiple of 4. I meant to say multiple of 4. So I'm going to break that up into x to the 8th times the 4th root of x to the 1st. And then, of course, 256, that's a perfect 4th root, 4. X to the 8th is a perfect 4th root, x squared. And what I have left in the radical is the 4th root of just x. Another thing to note here is that another way of thinking about this is with our properties, x to the 8/4 is the same as x squared. And so that's how we're able to change x to the 8th, the 4th root of x to the 8th is x squared, because x squared times x squared times x squared times x squared is x to the 8th. We're going to do the same process with 13 here, and this we're breaking up square roots. So remember, if there's no number here in the index, it is a 2. We just don't ever write that. And so this is going to be square root of 81, I know is a perfect square. Square root of x to the 6th is a perfect square because 6 is a multiple of 2. And then y to the 5th, I'm going to have to break apart a little bit into y to the 4th times y to the 1st. So 81 is going to be 9. X to the 6th is x cubed, y squared, and inside the radical, I have left just y. And finally here we have 125 to the -1/3. Okay, well I know that if I have something to a negative power, I can take the reciprocal of that and make the power positive. And to the 1/3 power is the same as the cube root, because remember the denominator is the index of the root, so it's a cube root of 125 to the 1st power, which nobody ever writes anyways. And 125 happens to be a perfect cube. This is a fun little math book puzzle. and we have 1/5 as a equivalence. 125 to the negative 1/3 is the same as 1/5. So that's questions 9 through 14, and we'll wrap this up here in the next video with I repeated the numbers accidentally, so it will be the bottom for 11 through 14.